It'll go quick. All right, ready? Let's do it. All right. Learn Target 11. We're gonna talk about solutions. Okay. So it'll be just a little math based, but just the first couple things that I want you to write down are just a couple definitions. Okay. Um, Bam. Okay, so solutions just mean this. You guys have made solutions all the time. Who's made Kool-Aid before? Who's put salt in water before? Okay, congratulations, you made a solution. Okay, so you take a solid and you dissolve it in water. All right, and there's some theory and stuff behind it. Okay, that why things dissolve and why things mix. We're not going to really get into that, but what we are going to do is we're going to talk about how we talk about. We're going to talk about this thing called concentration. Okay, so a solution is anything that's a solid that is dissolved in water. The solvent, this is kind of a fancy word. The solvent is what does the dissolving. So usually it's water. All right. And then the solute, okay, like solute, but solute is what is being dissolved. All right. In some rare cases, who's ever used like a two-stroke engine before, like a leaf blower or like a snow blower? Anybody? Okay. You may have heard of mixed gas before? You know what I'm talking about? Mixed gas. Anybody ever heard of mixed gas before? Just Regal? How do you make mixed gas? Does anybody know? You mix with oil, okay? So they mix, right? You want it to mix. So gasoline's clear when it comes out, but then some of these engines that you use, like a leaf blower and stuff like that, you have to mix it. So the oil is what is being dissolved, and the solute then in that case would be the gasoline, okay? It's mixed oil, like 40-1, right, Wyatt? Or whatever it might be. Ice auger, you ever use those? The gas ones? Yeah. That's another type of thing. Okay, another vocab term, okay? Something that is unsaturated means that it's like you can't really, everything's dissolved. Okay, something that is saturated, that's how Mr. Tyson likes his Kool-Aid, okay, is there's solid on the bottom, right? It's just like you pour so much solid in that it won't dissolve anymore, right? Who's seen that in Kool-Aid before? Yeah, I like that kind of Kool-Aid, right? So it's saturated, there's solid on the bottom, as you can see right here. Okay, and then if it's unsaturated, you could always dissolve more. All right, so if you poured water or salt in water, you mix it, it all dissolves. You could add more, mix it, and it keeps dissolving. That's kind of the way how we talk about saturated and unsaturated solutions. All right. Mm-hmm. Okay. What do you need, Emma? This word? Solid. That's bottom. That's bottom. Solid on the bottom. Like you poured so much Kool-Aid in there, it's on the bottom. You know what I'm talking about? Okay. Good? Okay, so for the formula for molarity is this. Okay, big M. That's what we're going to talk about, this thing called molarity. What is molarity? All right? So molarity is big M like that, okay? And moles over liters. And kind of what we talk about when we talk about molarity is this. I'll let you write that stuff down first and then I'll talk. Where? Moles is the number of molecules in a given liter, okay? The moles number of molecules in a given liter. We're going to make Kool-Aid. I can't remember, probably Tuesday. We'll make Kool-Aid. Sound good? We drink it. It's fun. We make scientifically calculated Kool-Aid. So that's kind of what we're shooting for. All right? Have a Kool-Aid party. Get that purple drink. You know? Purple Kool-Aid. I got it. Picked it out. Charcoalberry Fin is what I picked out, I believe. It's called Charcoalberry Fin.
What's
like
it taste like?
I don't know. Like kiwi and like cherry and stuff. Yeah, I think it's yummy. We'll make it eventually. Okay, let's talk a little bit about molarity. So when we talk about solutions, okay, it's easy when we talk about like, who's made Kool-Aid before taking a sip and like, this sucks. Or like Gatorade powder, you know what I'm talking about? Where you're like, this is just not like, just doesn't have enough, right? Well, that's how we kind of talk about things in our world is like how much sugar is in a drink, right? Like it's not very concentrated, okay? So when we talk about terms of molarity, you have this big, jug of whatever it may be, right? Like this, okay, a glass of water, okay? And when you start adding like sugar to it, you're introducing, the molecules that are floating around, right? You're introducing a number of atoms, which is the moles. So you're introducing a certain number of atoms or molecules into the solution, right? But when things start not tasting well, we would say it's not very concentrated. When we talk about concentration, we talk about how many molecules are in a given amount, okay? So in chemistry, how we express concentration, okay, is how many molecules are in a given liter, all right? So for example, we say that, like you've heard me say this before, you've heard me say I have a 1 molar solution of hydrochloric acid, correct? Who's heard me say that before? And I've said that before. What I'm saying is if you have 1 liter of water, you have 1 mole dissolved in it, okay, of hydrochloric acid molecules. Now, 1 mole is 6.02 times, don't have to write this down, I'm kind of just explaining it to you, okay, is 6.02 times 10 to the 23rd. So that's how we express concentrations when we talk about solutions. We say 1 molar. Now, if I have this thing called a 12 molar solution, okay, it's a big M, 12 big M, okay? What this is implying is you're implying that in that same given liter, okay, you have 1 liter, you have 12 moles of hydrochloric acid. So you have 12 times 6.02 times 10 to the 23rd. Now, which one is more concentrated is really what? Is the 1 molar or the 12 molar have more molecules?
12.
The 12, right? It's got a lot more, okay? And therefore, it's way more concentrated. So when I get hydrochloric acid, okay, from the chemical company, it looks like this, okay? It's in this big jug, and this is 12 molar hydrochloric acid, okay? So this is super, super concentrated with bad stuff, okay? 1 molar, what I do when I'm gonna give you guys 1 molar is I take it and I dilute it, okay? So I add water so there's less molecules in there. So if you think about it, if I put my hand here and I put my hand here in 1 molar or 12 molar, I just like put my hand in a pan full of goldfish if it's 1 molar, or put my hand in a pan full of piranhas, okay? Because the more concentrated it is, the more molecules there are to do stuff, okay? So the 12 molar, which would be this, I have 12 moles for every 1 liter swimming around, is a lot more concentrated, all right? And the same goes for like when we drink Kool-Aid. The more molecules I put in there, the higher the molarity is gonna be. That's the stuff we like to drink because it tastes good on our tongue, right? If I have a smaller molarity, it doesn't taste that great, okay? Because there's not as many molecules swimming around. Does that make sense, everybody? Kind of? So the bigger the M, the higher the concentration. But we express things in terms of big M in chemistry, molarity, all right? It's the number of molecules for a given liter there, okay? So to use this equation properly to figure out the molarity of solutions, you can only use moles and liters, all right? So part 1 asks this, okay? Now we'll start getting to the calculations because you got the theory part down, all right? Number 1 asks this. we have molarity as moles over liters, okay? If you dissolve 0.461 moles into 1.32 liters, what is the concentration going to be? What is the molarity? Concentration is big M, okay? That's what's the big M going to be, all right? So how I do that is I go, okay, I need 0 big M is equal to 0.461 moles over 1.32 liters. And that is it, honestly. Okay, so you take your calculadora and you take 0.461 and you divide it by 1.32. Okay, holla at me when you got your question or you got the answer. 0.34, and we're going to say big M. That's how we would report the final answer like that. Okay, so you literally just take moles. It's got to be in moles, and it's got to be in liters. Okay, let's do the next one. Molarity is equal to moles over liters. Okay, so I'm going to take 4.53 moles and divide it by 2.85 liters. That's what I'm going to solve for big M. All right, everybody see where I got those numbers? You just plug them right in. It's just plug and chug now, okay? The molarity then is going to be like 1 point something? 1.58. 1.58 big M, okay? See if you can set up the last one here quick. What is the molarity of a solution? What'd you get, Spencer? 0.001 big M. Yeah? Is that it? Okay, here's what you're going to do. You're going to go to your enrichment right here. Part 1, 3 problems just like that. See if you can do it. Take a break after. Sound good?